Hello everyone, I'm Ding Lei from Tencent News. As an automotive industry observer, I've always been thinking about how to better tell China's story and the story of automobiles, and how to convey them to users in the most appropriate way. That's why I invited my old friend, Professor Zhu from Tongji University, to co-launch this podcast dialogue series. So just now we also talked about some topics related to technology. Let's continue with this discussion. Earlier, you mentioned two aspects of new energy vehicles. One is electrification, and the other is intelligence. Let's start by talking about electrification. You just mentioned that among the technological changes at the auto show, what impressed you most was the flash charging technology. Specifically, the changes in BYD's flash charging. Why do you think this flash charging technology has become so significant in the past 1 to 4 months, or even in the entire context? This is a very important technology in the process of new energy transformation, right?
From this auto show, I feel that in terms of new energy, one highlight is the flash charging at the BYD booth. Another is the 4 types of batteries showcased at the CATL booth. The 4 types are sodium-ion batteries, lithium iron phosphate batteries, ternary lithium batteries, and condensed-state batteries. After seeing these 2 booths, I feel that the electrification of passenger vehicles is basically coming to a close. It's reaching its final stage. Of course, technological and engineering innovations will always be needed. But as for disruptive innovation, I think the era of new energy passenger vehicles is over. The first hurdle for automotive electrification is the power battery. Over the past 10 years, China has taken the lead in establishing a complete industrial chain for new energy vehicle power batteries. The price of batteries has dropped by nearly tenfold at least. Now, the price of these batteries has already fallen to a level that can support mass production on a large scale and is enough to rival the cost of internal combustion engines. So that's the first hurdle. The second is the range anxiety of the whole vehicle. So now we can see that a long driving range of 600 to 900 kilometers has already become the standard configuration for electric vehicles.
Or base models.
Past 600 kilometers, range anxiety is gone.
That's right.
So starting from last year, super fast charging has already brought charging power up to the megawatt level. So from 100 kilowatts, 300 kilowatts, last year it already reached the 1 megawatt level. That's 1,000 kilowatts, right? This year, BYD's flash charging has increased from 1.5 to 1.5 megawatts, which is 1,500 kilowatts. So 5 minutes, 9 minutes in low temperatures, plus another 3 minutes. This is a very typical 593 setup, right? So the final step in energy replenishment, BYD's flash charging has already made charging very close to refueling a gasoline car. So basically, with a real-world range of over 600 kilometers, range anxiety is basically gone. It's now turned into charging anxiety about energy replenishment. But with super fast charging and flash charging, that gap is being filled.
Especially with flash charging.
So basically, electric cars and gasoline cars are now very close when it comes to energy replenishment.
Yes.
So from this perspective, I think the era of disruptive innovation for new energy vehicles, the era of disruptive innovation is probably over.
We've already reached that stage.
Now, when it comes to all-solid-state lithium batteries, I think this is about battery technology. Technological development and innovation are still needed, but as for all-solid-state lithium batteries, yes. For cars, especially passenger vehicles, they probably won't rely on them.
They're not the core application focus.
Their standout advantage is higher energy density. They might break through 500 watt-hours per kilogram, but for all-solid-state lithium batteries, what really matters is the real demand probably comes from things like drones, especially for low-altitude, low-power flight. So with our current ternary lithium batteries reaching 280 watt-hours per kilogram, even with that, it's still very difficult for drones to stay airborne for more than 40 minutes. If we had solid-state lithium batteries, it might be possible to reach over an hour of flight time. As for fuel cells, like Toyota's fuel cell vehicles, we can see that mass production hasn't really succeeded so far. So the reliance of fuel cells on hydrogen may not be a real necessity for passenger cars. Instead, it's more relevant for drones, if we use hydrogen to power these low-altitude flying vehicles. Now, autonomous flight time can already reach 2 hours.
Fuel cells and solid-state batteries are primarily for low-altitude use.
When we talk about batteries, whether it's sodium batteries, lithium iron phosphate, ternary lithium, semi-solid all solid state, or hydrogen fuel cells, when it comes to cars, the main technologies are still ternary lithium and lithium iron phosphate. Lithium iron phosphate has already achieved support for 1.5 megawatt charging. Yes, ternary lithium batteries have also achieved support for 1 megawatt ultra-fast charging. So In this regard, we hope that the technology can converge as soon as possible, because if we keep disrupting and disrupting, the R&D cycle becomes too fast, which will seriously affect the profit margins of car companies and the industry as a whole. So if you want to be a strong automotive nation, how do you become a strong automotive nation? You need to have enough tax revenue. Your companies you have to create value, right?
Exactly.
So the fact that this thing has never been profitable is still a problem.
Yes.
That's why we hope that for the electrification of passenger vehicles, the pace can be slowed down.
Slowed down.
Yes, so this year we've seen, starting from last year, that it's already possible to achieve megawatt level ultra-fast charging. After BYD made their announcement, you could see that Geely followed suit. Geely also followed up. From the battery perspective, after BYD's release, CATL also followed. So this shows that achieving megawatt level charging is possible. Now, with our current batteries, by optimizing the batteries and improving the thermal management of the battery packs, by using energy storage systems at charging stations, we can mitigate the impact of megawatt-level charging on the power grid. Also, the engineering design of liquid-cooled cables and liquid-cooled charging guns is getting better and better.
Yes.
So the biggest advantage of this flash charging, the trapezoidal flash charging pile, doesn't it look a lot like a gas station?
Yes.
And the user experience is already very close to refueling at a gas station.
Right, you can flash charge on one side and fast charge on the other.
Therefore, I think that disruptive innovation in new energy passenger vehicles is probably over.
Then,
to be perfectly honest, I really do hope that modern high-speed flash charging technology will eventually stop being marketed and promoted, based solely on technical specifications and raw numbers.
You also called for action on this issue on Weibo a couple of days ago.
Because
why? Why do we need to make this kind of call?
Look at that. With the shift to new energy, meaning electrification and intelligence, hasn't the process of innovation brought about many safety risks? Some of the safety hazards were revealed by traffic accidents that started to emerge last year. Since last year, we've started revising or newly establishing mandatory national standards. Yes, we've revisited and managed these safety hazards from a societal perspective. For example, hidden door handles have been restricted, and the 0 to 100 kilometers per hour acceleration time has also been limited. The trend of moving most controls to virtual buttons and voice commands on the screen is also being restricted. Regarding autonomous driving, safety requirements for combined driving assistance systems have been introduced and restricted as well. This means that during the process of rapid and high-paced innovation, safety hazards inevitably accompany innovation. So could fast charging also have this problem? What worries me most is this: even with 5 minutes, 9 minutes at low temperature plus another 3 minutes, the results are already very impressive. But as charging power increases, after all, with current lithium batteries, liquid electrolyte lithium batteries, their fundamental safety issues haven't been resolved. Yes, instead, improvements have been made through electromagnetic enhancements and thermal management of the electromagnetic pack to suppress these issues. So what we're worried about is, if you can do it in 5 minutes, I'll do it in 4.5. If you can do it in 9 minutes, I'll do it in 8.5. The ones who come later always want to be a bit faster than those who came before.
It's an endless race for specs, but many are just lab parameters from extreme conditions.
I think 5 minutes or 9 minutes is already good enough.
Yeah, exactly.
So from a physics perspective, as charging power increases, concerns about safety and battery lifespan also increase. There definitely are, right? Yes, it's already established from a physics standpoint, isn't it? So from this perspective, that's how I feel. As technology develops, can we avoid taking on innovative safety risks and only managing them after the fact? This time, can we call on the government to implement proactive management in advance? Yes, in other words, can the super-fast charging speed, like the 5 minutes plus 9 minutes plus 3 minutes first released by BYD, be set as an industry standard? Because company standards become industry standards, and industry standards become national standards. That's how it works. This is actually a routine process in the formulation of automotive standards. For example, the US automotive charging standard comes from Tesla, right? So can we first fix 5 minutes, 9 minutes plus 3 minutes as an industry standard? Put a stop to this kind of parameter-based marketing,
right?
Basically, we shouldn't keep pushing for faster and faster speeds. What if it gets so fast that it ends up breaking down? Yeah, so instead of waiting until problems arise and then going back to impose restrictions, why not set limits from the very beginning?
Exactly.
So after this industry or national standard is established, even if there are faster methods, maybe we should just keep things steady for 2 years first.
Yes.
Well, once the fundamental safety issues of the battery are truly resolved, meaning the cell itself is inherently safe. For example, with sodium batteries, the Chinese Academy of Sciences has already published a paper in Nature about a new type of liquid electrolyte called PNE. When it reaches 150 degrees Celsius, it can transform from a liquid to a solid, naturally isolating and preventing short circuits. This technology has already been implemented in sodium batteries. So using the same approach, is it possible to find a new material for liquid lithium batteries that can also achieve this kind of natural isolation to prevent short circuits? So once the safety of the battery cell shifts from relying on thermal management to having inherent safety, then we can focus on increasing charging speed. That's why I believe the emergence of ultra-fast charging is a new technological breakthrough, and it could even mark the completion of the development of new energy passenger vehicles. But, well, I hope that the relevant government authorities will introduce industry or national standards, initially setting the benchmark at 5 minutes, 9 minutes, plus an additional 3 minutes for low temperature conditions. As a national or industry standard, let's set it first.
Yes.
Don't make it any faster.
Right. This is to avoid only regulating after incidents have already happened.
In the past, our innovations in new energy and intelligent technologies have followed a path where rapid participation in innovation led to safety risks, and then increased regulation was introduced. Isn't that right? So, can we implement preemptive regulation for ultra-fast charging? Because in the end, it relies on the compatibility between charging stations and vehicles. To achieve ultra-fast charging, the battery installed in the car needs to be optimized in 3 aspects together. Currently, charging stations are being rapidly deployed, so charging is getting faster and faster. If a problem arises, a safety hazard, the cost of going back and fixing it would be truly enormous.
That unit is basic infrastructure.
That's right.
The investment is massive.
Yes.
So if you really
want to have one station every 3 kilometers in big cities and every 5 kilometers in small cities, my goodness, that's an enormous amount of social capital investment.
Exactly.
So at this point, I think when it comes to charging speed, we can't afford to innovate recklessly anymore. If we have to go back and manage safety risks later, that's something we simply can't handle.